All right, so we're looking at lesson 12 today. We're going to look at work, power, and energy. So hopefully after this lesson you'll understand work, power, and energy. When we use the word work in physics, we actually mean mechanical work. We define positive mechanical work to be a force that's acting through a distance that is in the direction of the force. The amount of mechanical work accomplished by a person or a machine is defined as the product of the net force and the distance through which the force acts. So if you want to write down that formula, you can. Work equals force times distance. The unit of work is typically 1 Newton meter, called a joule, and it's in honor of the British physicist James Prescott Joule. He was born in 1818 and died in 1889. Torque and work have the same units. They're both Newton meter, but torque and work are different. So 1 Newton meter is a joule only when it refers to work. When it's dealing with torque, you keep it as Newton meter. Work has a magnitude, but it does not have a direction. So work is not a vector quantity. It's just a scalar quantity because the amount of work is just defined by a number. You can't give a direction to work. Energy is a measure of an ability to do work, and it's also measured in joules. For now, we're just going to remember that energy and work are almost the exact same thing. They're different, but we're going to just focus on that they are very, very similar right now. Power is defined to be the rate at which work is performed or the rate at which energy is consumed. So average power is the work performed divided by the time it took to do the work. So your average power is work divided by the change in your time. And that's a delta. It just means change in time. So if you want to write down that formula, that would probably be good to do. 1 joule per second is called a watt, and it's in honor of the Scottish physicist James Watt, that was born in 1736 and died in 1819. So if you're noticing a trend in science and in math as well, if you create or invent something, usually it gets named after you. So if you want your name to live on, go create or invent something in science or math. So let's look at an example. A force of 42 newtons is applied in the direction of motion of a block for 4 seconds as the block moves 12 meters. How much work is done and what's the average power? So work equals force times distance. So we're looking for our work. Our force is 42 and our distance is 12. So if you multiply those, you get 504. That's 3 sig figs. 42 and 12 had 3 significant figures, so we're going to keep all 3. And then the units are joules because we're dealing with work. So that would be your answer. For B, what is the average power? Your formula is wattage divided by the change in time. So not wattage, work divided by the change in time. So our work was 504 and the change in time was 4 seconds. So if you divide that, you get 126. 4 also had 3 sig figs, so we still keep the 126. And then watts is your units. So that would be your answer for that one. We're going to look at another one. A man exerts a 400 Newton force to pull a wagon. The force is inclined to the horizontal at an angle of 33 degrees. The man pulls the wagon a distance of 12 meters in 10 seconds. How much work does he do, and what is the average power consumption? So the first thing we have to do is to make a triangle over here. And we need to know how much work he does. So we only need to figure out the force that is perpendicular to the direction of motion, that is parallel to the direction of motion. So only need to worry about the x component here. We don't care about the part that he's pulling up. That doesn't matter because we only want to know the part that's going in the 12 meter direction. So that's going to be found from 400 cosine of 33. So that's going to be your force. You're only going to use the x part of it. So work equals force times distance for part A. So we're looking for the work. Our force is 400 cosine of 33, and our distance is 12. So you should get that for your work. And the 400 has 3 sig figs, but the 12 only has 2. So our answer is only going to have 2 significant digits. So it's going to be 4,000 with a bar over the first 0. And then the units on work are joules. And so that would be your answer. For part B, what is the average power consumption? So power is average. You do work divided by the change in time. So our work, we don't use 4,000. We use this whole decimal that we had up here, because we always use the whole number in our calculations, and we only use sig figs for our final answer. And it says the time, the change in time was 10. So if we divide, we're going to get 402.56, and we still only have we only have 1 significant figure here, because 10 is only 1 sig fig. So if we do 1 sig fig, we would have 400, and then your units on power are watts. So 400 watts would be your answer there. Okay, so now we're going to look at one more example. We have a 40 kilogram block lifted vertically with a constant velocity, a distance of 16 meters in 5 seconds. How much work is done? What is the average power consumption? So work is force times distance. So the force is the same thing as the block, but they give it as a 40 kilogram block. So we need to figure out the weight of it. So the force is going to equal the weight of the block, and the weight is mass times gravity. So our weight, mass is 40, and our gravity is 9.81. So our weight, which is the same thing as our force, is going to be 392.4. So that's our force that we're going to use, 392.4, and it says the distance is 16. So we're going to multiply that by 16, and I get 6,278.4. Now, how many sig figs should we have in our answer? We should only have 2, so we're going to round this to 6,300, and then the units on work are joules. So that would be your answer for part A. For part B, what is the average power? So the average power is the work over the total change in time. So our work was 6,278.4, and the time was 5. So if you divide by 5, we should get 1,255.68. And we still have 2 sig figs, so that would round to 1,300. And the units on power are watts. So that would be your answer for part B. So they're not terribly difficult. You do have to know how to use the formulas for these. So don't worry about memorizing the formulas. Make sure you're just putting them on your note card as you need them for your tests. Okay, so your homework is 1 through 20, and then the curveball questions 1 through 5. So make sure y'all do those tonight.